So next we're going to talk about a different angle measurement. Up till now you've only looked at angles that are being measured in degrees, but there is another unit of measure that we can use for angles, and that is what we call radians. Think of radians as you would a larger unit of measure. Let's talk about distance for a minute. When you talk about distance, you've got miles. You can measure distance in miles. You can measure it in feet. You can measure it in inches. So radians, think of radians as a much larger unit of measure. So think of radians as you would, for example, a mile. So for example, 1 mile is equal to 5,280 feet. So radians actually can take that larger distance and you have it broken up into a smaller unit. So angles is what you think of as feet. So angles, 360 degrees is equivalent to 2 pi radians. So 2 pi radians is a much smaller number versus the 360 degrees. So it's measuring a larger angle in terms of a smaller number. So what a radian is, it's the measure of a central angle that intercepts an arc whose length is equal to the radius of the circle. And the measure of such an angle is a radian. So here's my central angle. So 1 radian, you're looking at a portion of the circle. It's a measure of that particular arc. So 1 radian is equal to 180 over pi, which is about 57.296 degrees. So that's what, and give you an idea of what 1 radian is actually equivalent to in angles. So now when we talk about angles, we also use other vocabulary besides degrees and besides radians. We also can use this phrase revolution. So 1 revolution is actually equivalent to 2 pi radians. Radians is a unitless measure. We don't actually have a symbol like we do for degrees. If you're talking about a measure of an angle and there's no units, then you know it's going to be a radian versus a degree. And 360 degrees is actually equal to 2 pi radians. So 2 pi radians is 1 complete circle. So 180 degrees is actually equal to 1 pi radians. 1 degree is equal to pi over 180 degree radians, and 1 radian is actually equal to 180 degrees over pi. Like I mentioned, radians is unitless. If you have angles measured in degrees, you're going to have to write that degree symbol. So this becomes very critical. You can't leave off now this degree symbol, because if you leave off this degree symbol, then when I read it, I'm going to be reading it as a measurement in radians. And there's a huge difference in the length or the measure of an angle when you express it in radians versus degrees. So radians can be expressed in exact form, and when we say exact form, it's going to be with pi. So you're not going to be picking up the calculator. Most of the time, an exact answer is always better than approximation. An approximation is the minute you pick up your calculator and you multiply out that pi symbol. And remember, there is no symbol given for approximate radians. So the first thing you want to be careful of is making sure what unit of measure you're dealing with. Are we dealing with degrees or radians? So 57, again, you see the degree symbol, so I know it's going to be degrees. When you just see 57, notice there's no degree symbol. So if I see 57 written, that's going to be an angle in radians. 57 pi, again, there is no degree symbol, and again, this is an exact angle measurement, so this is going to be radians as well. So this I know is exact because I see the pi symbol. 57 with no pi symbol, this is going to be approximate. This is an approximate radian measure because they've multiplied out the pi. So until your brain gets really comfortable thinking about degrees and radians, you're going to be converting a lot in the beginning until you become more comfortable with radians. Because in our study of trig, we're going to be looking at exact radians more so than degrees. So you can convert to help you get used to this particular unit of measure. So again, a full cycle around the circle results in a trip of 360 degrees, or 2 pi radians. Therefore, 360 degrees is equal to 2 pi radians. So these are your conversion formulas you're going to need to remember. To take an angle in radians and convert it to degrees, you're simply going to take that angle and multiply it by 180 over pi. To go the other way from degrees to radians, you're going to take that angle and multiply it by pi over 180. So to convert the following from degrees to radians, what we're simply going to do is take our degree, multiply it by pi over 180. And remember, when you multiply fractions, you're just going to multiply straight across. Now, another way to remember is that pi over 180 or 180 over pi. Remember, radians is not going to have the degree symbol. You need to get that degree symbol to cancel out. So when I multiply these fractions when I multiply the numerators and denominators straight across, notice I can cancel out the degree symbol. So notice I can simplify this fraction to 7 pi over 18. So 70 degrees is equivalent to 7 pi over 18 radians. So to take 210, I'm going to take 210 degrees over 1, multiply it by pi over 180 degrees. So I'm going to have 210 degrees pi over 180 degrees. Notice the degree symbol is gone. And I can simplify. I can simplify that particular fraction down to, that's going to give me 21 pi over 18. And I can also divide out a 3. So that's going to give me, 7 pi over 6. Okay? So now I can sketch this angle, because the second part of the directions asked me to draw each angle. 70 degrees I know is going to be in quadrant 1. And again, I'm going in that counterclockwise direction. 210 degrees, which is equivalent to 7 pi over 6. Again, there's my initial side on the positive x-axis. 210 degrees I know is 30 degrees more than 180. So I know I'm going to be down here in quadrant 2. So negative 190. Again, I'm going to still take this, and I'm going to multiply by pi over 180 degrees. So I have negative 190 degrees pi over 180 degrees. So that's going to give me negative 19 pi over 18. So when I draw negative 19 pi over 18, I know that negative 190 degrees is 10 degrees further than negative 180. So again, I know that I'm going to be going in this clockwise rotation. So there's my negative 180, so I need to go another 10 degrees. So there is my angle measurement of negative 190 degrees. Negative 566. Again, I know I'm going in a clockwise direction because, again, I know that I've got this angle is greater than negative 360. So I know I have to go around 1 revolution. So I have to take 566 degrees, and I'm going to subtract from it 360. Again, I'm talking about a distance, so it's okay to ignore the negative sign. So 566, take out that 360. So that's going to give me 206 degrees further that I have to go. So again, when I know that that's going to be more than 180, and I have to go another 26 degrees. That's also going to put me there in quadrant 2. Again, remember, the negative sign is just showing me the direction of the angle. So now to convert into radians, I'm going to take negative 566, multiply it by pi over 180. And again, if you want to use your calculator to help you simplify the fraction, negative 566 divided by 180, and then math fraction, that's negative 283 over 90. And that's the equivalent to, so that's how you can convert a degree angle measurement into radians.